In this video I'm going to be talking about normal distributions and standard normal distributions, and I want to show you how to use the calculator to find an x value or z-score when you're given a probability. I've got an example demonstrating the setup for the type of problem you might be answering. And this is a normal distribution curve, and the mean is 24 and the standard deviation is 2. And the area that's shaded under this curve is about 90%. I have limited control on how to set the area, but it's pretty close and it's good enough for this example. So this shaded area is 90%, and the question might be, find the value of x that separates the bottom 90% of the distribution from the top 10% of the distribution. We can use the calculator to find x. I'm going to go into the distribution menu and get the function inverse norm, which is the third function down. Now, inverse norm in this context is going to take 3 inputs. Once you've identified the location that you want to find the value of, meaning this x value, you want to give it the area to the left of that location. And in this case, in this diagram, that's 90%, so I'm going to give it 0.9. Next, I give it comma and then the mean, and then comma and the standard deviation. The next one, then when I press enter, it's going to return the x value that separates the bottom 90% from the top 10%. So let me emphasize something here. The first input is the area to the left of the location that you're looking for. So it may be helpful to you for the first several problems to sketch the distribution curve and shade the areas as they're given in your problem statement. Then you can see the x location that you want and be able to pick out the area to the left of that in order to enter it into inverse norm. Now let me do another example that's similar to this. Okay, in this problem I've got my area shaded to the right, into the right tail. So let's suppose the problem says you're supposed to find the value of x that separates the top 5% of the distribution from the rest of the distribution. So the area that you're given, or what you shade, is to the right of the location that you want. In order to answer this question, it's really very similar to the question I just did, you need to recall that the entire area under the curve is equal to 1. So if we know what this shaded portion is, if we know it's 5%, then we know that the remainder, this unshaded part, is 95%. And that's the value that we need to enter into inverse norm in order to find x. So basically, depending on how your problem's given, you might need to make use of the fact that the entire area is 1. And if you're given the area to the right of the value that you want, use the subtraction to get the area to the left. So to answer that question, or to find that x location, I'm going to give it inverse norm, and then the area to the left is 0.95, and then comma the mean, comma standard deviation, and it returns an x value of about 27.29. So again, very similar to the last problem, a good idea to sketch the curve and shade the areas as they're given in your problem statement so you can see your x location, and then you can pick out the area to the left of that value in order to find x. The next example I want to do has to do with the standard normal distribution curve. So let me bring up a diagram of that. Problems involving the standard normal distribution work a lot like the regular normal distribution problems. In this case, the mean mu is 0 and the standard deviation is 1. And what I wanted to point out here is when you're using inverse norm and your problem has to do with z-scores and standard normal distributions, you actually don't need to specify mu or sigma in your inputs. So let's suppose the problem is this. What is the z-score that separates the bottom 10% of the distribution from the top 90% of the distribution? So basically we're looking for this location, this is z value, that separates the bottom 10% from the top 90%. And to use inverse norm to answer that question, your input's simply going to be the area to the left of z, which is 0.1, and then enter, because the calculator is going to default to mu equal to 0 and sigma equal to 1. So that works a lot like normal CDF does with standard normal distributions, where if you leave it off, it's going to assume that that's what you're talking about. Okay, so that gives you the z-score for that situation. So it works a lot like the regular normal distribution problems. Now the last problem I want to show you has to do with being given the middle percentage of the distribution that's centered on the mean. And I have a diagram to show you what that looks like. Okay, this is a somewhat complicated diagram, but we're going to only look at a few parts of it. It is a standard normal distribution curve, and so those are z-scores along the horizontal axis. And you can see that the area under the curve is divided into three portions. You have an area of 5% or 0.05 in this left tail. Likewise, you have 5% or 0.05 in the right tail, and then the middle portion is 0.9 or 90%, and that's centered on the mean. So this is a symmetric distribution or symmetric breakdown of the area. So the question might be something like this. Find the range of z that bound the middle 90% of the distribution. So what are the z values what is the range of z that encompass the middle 90% of this distribution? And so to answer that question, when it's asking for a range of z or a range of x, you're actually going to need to give it two values to answer that question. The lower bound on the range and the upper bound on the range. And when you sketch it like this, you can see the lower bound is this line here separating the shaded portion from the unshaded middle part. And on the right, again, the location separating the shaded portion from the unshaded middle region. And so basically I'm going to use inverse norm twice to find these two locations. Because it's a standard normal distribution, I need only give it the areas. And for the left bound, or lower bound of this middle region, the area to the left is 0.05. And I get a z value of negative 1.65. For the right side, the right bound on that middle portion, I'm going to use the area to the left, and keep in mind that's going to be the middle portion, 0.9, plus the area in the left tail. So I actually want to input 0.95 to find that location. And you get 1.645, and you can see there's some symmetry involved, as we would expect, since this is centered on z equals 0 and it's symmetric on both sides. Let me do another example really quickly. Let's suppose the middle region that you want to find the bounds on is 80%. Okay, so this middle portion is 80%, and we want to find the range of z that encompass that middle 80%. And to find the lower bound or the left bound on that range, I'm going to use inverse norm, and the area to the left of that is 0.1. So that returns a z-score of negative 1.28. The area, pardon me, the z-score to the right of this middle region can be found using, now I'm going to give it the area to the left of this particular location, which is going to be 0.8, plus the area in the left tail, which is 0.1. So that's going to be 0.9. And again, z-score of 1.28, which is the same but for the sign as the other z-score due to the symmetry of the problem. Okay, so that's the situation where you're asked to find the range of z or the range of x for some middle region of the distribution, and you're actually going to find two answers, and it's always helpful to sketch the curve and shade the area as it's divided into three sections. Okay, so that's all I wanted to show you for how to use inverse norm to answer various kinds of questions involving normal distributions and standard normal distributions. I hope you found it helpful. These worksheets, by the way, are available for you to play with at purplemonkeymath.com. When you're actually going to input answers for your homework, you should rely on your calculator, as sometimes these will round off values more so than your homework will require of you. But they are helpful for playing around and getting a feel for how probability works in conjunction with x and z under the normal distribution or a standard normal distribution curve. Thanks for watching.